Today's topic is about the science behind weight loss and the basic physiology and common questions I came across, right? By me, Coach Seth. So, introduction. Weight loss is seamlessly really simple. Eat less and move more. While that may be true to a degree, what goes underneath the hood is really a complex physiological process. We think that understanding the whole process and science behind fat loss might help you successfully complete your weight loss journey. After I explain some of the processes here, I'm going to give you the answers to some of the common questions that we come across, right? So what is fat? First place we need to start. So fat or deposits are usually divided into two different types. So you have your subcutaneous and your visceral. So subcutaneous fat represents the fat deposits found underneath our skin, while the fat deposits around our abdominal organs are the visceral fat. So visceral fat is metabolically active, producing certain molecules that cause inflammation in the body. So fat is distributed differently for men and women. So men tend to carry their fat around their abdominal area, while women tend to carry their fat around their thigh area, as well as women generally have a higher body fat percentage than males, which you're probably saying, yeah, Coach Seth, I know. Don't tell me that. So, and there's different hormones that come into play when it comes to men and women, and that's one of the reasons why is that men produce more testosterone while women obviously have a little bit more estrogen, right? So that comes into play when we're trying to lose weight, right? So it is demonized in the pop culture, but fat actually plays a huge role in maintaining a healthy body. It helps insulate and protects our bodies, provides energy, helps produce certain hormones, helps carry fat-soluble vitamins, and much more. So now fat tissue itself is split into two different types. You got your brown and your white fat. So your brown fat cells are smaller and rich in iron. When it burns, it produces heat without any shivering. This process is known as thermogenesis. Adults don't have large amounts of brown fat. That's why we focus on the white fat. The white fat cells are bigger than brown fat cells. They keep us warm, providing insulation, and we store a lot of them when we do brown fat. They are used for energy production and protection as a mechanical cushion. So how do we gain fat, right? So we know what fat is, but how do we gain it? So we store fat in adipose tissue in a form of connective tissue. It's made from fat cells, which are called adipocytes, and are separated by elastic and collagenous fibers. Technically speaking, we gain fat in two different ways. We have your hypertrophy and hypoplasia. So hypertrophy, that means that the pre-existing fat cells can increase in size. Then you have your hyperplasia, which means you form new fat cells, right? So two different things there, right? So we used to think that, when we're forming new cells, right, it only occurs when we reach puberty. But current evidence and science suggests that we can increase the number of our fat cells at any age. The exact mechanism of this is unknown, but the best guess is that fat cells reach their capacity and then get forced to make new ones. So it's a very important thing to remember that while we can produce new fat cells, we can't destroy the ones that already exist. So fat loss occurs when the pre-existing fat cells shrink in size, right? So now that we know there are two different types of fat cells and kind of how they're created, we can understand how it's stored. So fat metabolism starts in the intestines, where the fat triglycerides you ingest will be broken down into smaller fatty acids. All right, so these fatty acids, they're then going to form some free fatty acids. They're like in your membranes and kind of in your bloodstream, and then they're transported via the intestinal membrane. So as soon as they cross in the membrane, they will form triglycerides again. So then when these are kind of created, right, the carrier molecule called the lipoprotein are going to help kind of form everything there. So the package of that molecule gets too big in the bloodstream, so immediately gets pushed into your lymphatic system. And then after a long ride through the lymphatic veins and arteries, they arrive at the capillaries. So finally, once they reach the capillaries, they can either be stored in as fat after this, or go straight to the liver. So looking at this, right? So that's kind of the breakdown of how fat is transported and then how it's stored. It's either going to go right here into your liver, so you have a fatty liver, that's why, right? Or it's going to start getting formed in all the other areas, right? So now that we know how it's made, how it's stored, we can understand how we can burn the fat, right? So we get energy from fat tissue through 3 different stages, right? The first stage is called lipolysis, which occurs in the cytoplasm, which is basically, a fancy word of cell, right? Kind of how everything is created there. But again, we must break this down. So if it's triglycerides and the fatty acids and glycerol into a lipoprotein lipase. So these lipase get activated by hormones such as epinephrine, growth hormone, and glycone. So then we get into the next stage, which is mobilization of the fatty acid. They get transported in the cell by a protein called albumin. So the last stage of this is the beta oxidation. So oxidation, that means oxygen, right? So in this phase, the fatty acid gets converted to usable energy because the fatty acids can't get to the mitochondria by themselves. Carotene, another helpful thing in our system, right? Helps us transfer them. So looking at this stuff here, right? So you need oxidation, you need oxygen to burn the fat, right? And then we can use it to as energy. So your mitochondria, which is the powerhouse of your cell, this is a place where ATP is produced, adenotriphosphate, is your body's main energy source, right? So really the big thing here, what you need to realize is in order for us to burn fat, we need to breathe, right? So you need the more vigorous the movement, the more fat you're going to burn. So essentially, the more calories you burn, the more likely you're going to be burning fat, right? Especially if it's stored up. So now fat can also be burned during rest. You have your RMR, which is your resting metabolic rate, and your basal metabolic rate. So these represent the energy we spend during rest. That's the minimum amount of energy that we need to sustain your vital function. So if you're someone that just had like surgery, you're going to rely on these 2 things to kind of figure out exactly where you are in terms of what you're burning. So once we can figure out exactly what we're burning, we can understand where we can move that down the spectrum to do more, right? So the most significant percentages of this are used by your liver, kidneys, heart, and brain, right? So all the big function organs, right? They're going to be the kind of the powerhouse of exactly everything that you're going to be using. So now your resting metabolic rate, it's going to be about 60 to 70% of your total energy expenditure, right? Of exactly what you need. And then from there, your body's going to start breaking down stuff in terms of its calories, right? So now, what I mean by that, let's go down here. So it's fat burned during everyday exercise. So NEAT, or non-energy activity thermogenesis, represents the amount of energy burned during our daily regular activities. So this can include everything from planned exercise, sleeping, breathing, digestion, etc. So you can increase your body's NEAT exercises by just moving around more. For example, playing with kids, walking more, standing instead of sitting, more frequently cycling to work, etc. Going to Planet Fitness and doing a workout. That's another way as well, right? And so that's where we go right into our fat burning when weightlifting. So weightlifting is the higher intensity activity, meaning we usually get most of the energy from carbs stored in our muscles and liver. We can burn more fat when lifting by incorporating methods to make the sets last longer or increase the density of the workout. Those include supersets, circuit training, decreasing the rest amount of intervals, doing more reps, etc. Right? And then fat can also be burned during aerobic training. So the name itself tells us everything we know. Aerobic means that it's prolonged. You're using energy that's stored up. It's in breathing, right? So when you think of like aerobic stuff, the picture here, it looks like a step class, right? So it's something you're going to be moving a lot. So you're going to need a lot more oxygen for it. So a good way to think about this too is like looking at a sprinter versus a long distance runner. So a long distance runner, they're going to be going for a long time. So you're using a different kind of energy source versus a sprinter. It's real quick. So think of like Usain Bolt, right? The guy that runs, the 100-meter dash really quick. Like someone like him, he's going to be breathing, but it's going to be not as slow, right? So, and then, with both of those things, you have this thing called the, afterburn effect, right? So is that the EPCOS, excess post-exercise oxygen consumption, refers to the body's need to restore the oxygen after a workout. So again, if we want to burn fat, right, we need to breathe more, right? So HIIT workouts usually utilize energy systems that don't require a lot of oxygen, which means our bodies need to work harder to restore their resting metabolic metabolism after exercising. So after a workout, your metabolism stays elevated, and it takes some time for it to return to the baseline where it occurs, to where like the afterburn would occur. So now this is different for every person, right? There's no like right, set number, but the afterburn effect, from what they've seen, your body continues to burn calories after physical activity, but that's only about 6% of the calories burned during exercise for lower intensity activity, or up to 15% of those things for like, HIIT workouts, right? So you can increase your, metabolism by doing workouts by 6 to about 15%, right? But that doesn't mean that you should replace those calories. Because you're burning more doesn't mean you should be eating more, right? I think that's where a lot of people fall in the trap, right? Which goes right into hormones and weight, right? Hormones play a vital role in almost every bodily function. They help facilitate and regulate everything from sadness to hunger and thirst. Some hormones tell our bodies when we're hungry, while others indicate when we're fully, satiated, not as hungry, basically, right? So hormones that include feeling of fullness or the following: leptin, right? Which, people with leptin resistance struggle to lose weight. Having more body fat disrupts our leptin sensitivity. When we have leptin resistance, our body doesn't recognize the messages that leptin is trying to send us. So leptin is produced by our fat cells when they want to inform us that we've consumed enough fat to eat and should stop eating. Now, insulin's another one, especially if you're diabetic. People might notice that some weight gain is a side effect of insulin treatment. It's produced by the pancreas. Its primary purpose is to help regulate blood sugar levels and encourage fat storage. So if your leptin and your insulin are all out of whack, right, you're storing a lot of fat, and your body's not telling you when you should stop eating it, right, then, those things are basically, it's like a counterbalance, right? If they're not working together, then they're working against you, right? Then you have your cytokine cells and CCK, right? It's released by small intestines as a response to fat and protein. It stimulates the fullness centers in our brain, right? And there's a bunch of other hormones in here, right? Your oestrogen there. It's a hormone that opposes ghrelin, which we're going to go over in that. It's an appetite suppressant. And some other things like pancreas peptide, YY, and some other stuff like that. Basically what these things do, right, is they tell your body that you should stop eating, right? And so if you can control when you're eating, right, you'll be able to control how much you eat. So, which is going to help with weight gain or weight loss. And then some of the other hormones that come into play are cortisol, estrogen, and proestrogen, especially if you're someone that is female and getting up there in age, right? Those are those big hormones that are causing you to kind of stay where you're at with your weight, or having you gain weight, right? So what we want to do is make sure that all these hormones are moving in the right direction. That way everything's balanced out, and then we can make sure that our organs are working properly. Because when they're not working properly, if we're not doing the right stuff, then it's going to cause a lot of issues, and that's why you're going to have a constant weight gain, even though you feel like you're doing all the right stuff, right? So, the next thing that I always come across is, HIIT versus steady state cardio, right? So we talked about that up earlier on how like HIIT can help you, high intensity interval training, right? How it can help you burn more calories, but just because it helps you burn more calories in the short end, if you're only doing one thing a week, then the rest of the week you're not really doing anything, then that might not help you out. So that's where steady state cardio can come into play too. So your steady state cardio, it's easier to do, but one of the big things with it is it's boring, right? You can get really tired of it. If you're someone that likes to walk, it can be hard. Like, for instance, like it's cold here in Ohio, so going outside and walking is not very fun, right? It might be easier just to go do a class and burn a lot of calories. So you kind of have to find the things that work for you in where you're at, right? So calories in versus calories out, or hormones, which one should you pay attention to, right? The answer is both, right? So if your hormones are out of whack and you're not eating enough, right, then they're both just like kind of like what I talked about. Like, if they're all out of whack, then you're not going to lose weight, right? So we need to track what we're doing and figuring out kind of how we can get our hormones back on place, right? That's kind of the gist of everything, kind of what I wanted to go over tonight with everyone.